Hello, good morning, everyone, and thank you all for joining us for our DCP DevIncept contribution program, third edition weekend sessions, which are planned for you all so that you can learn a lot from industry experts. And today we are going to kick off this day one of our session on a Saturday. That's on a weekend. And these sessions are highly interactive, as well as you'll learn a lot of new things because we are going to be ultimately delivered by experts from the industry. And today, our speaker for today is going to be Ben Dechrai. So, talking a bit about Ben, he is currently working with Auth as a senior developer advocate, and also he's a community evangelist. He's a technology guy, okay, and he's been a software developer with a wealth of experience ranging from small MVP projects to large scale enterprise deployments. He's also passionate about working closely with developer and open source communities, and that's why he's here. And he has been coding since the age of 7, which it's a quite surprise, and a lot of students here in India don't do like that. So he's very passionate about coding and about technologies, and he's also helping developers, and he's also finding joy in doing that. So it's his passion. So without wasting further time, I think a lot of you are waiting for Ben to deliver the session. So let me just add him in the stream and let him take over from here on.
Hey everyone.
Hello Ben.
It's good to be here.
Thank you so much for joining.
You're welcome. Thanks for having me. I think that's probably one of the best introductions I've ever had. Thank you so much.
Thank you so much. And we have like more than 100 plus people live here on YouTube, and we are very much excited to listen to you. And yeah, so just
fantastic.
We are waiting for you to start.
Okay, cool. Well, I'll get started then. One thing I do want to say before I do get into the slides is that I know we'll have some time later at the end of it for Q&A type thing. But like was just mentioned, I love running these things interactively. So I'm going to try and keep an eye on the questions, the chat that's coming through. If I notice any questions coming through that are relevant, then I will talk about it beforehand. But please, there will be time at the end as well for Q&A. So without any further ado, if we can get the slides into the stream, we'll get cracking. Thank you. All right, so the intro's been mostly done, but just a quick overview about me as well. I am a software engineer. I've been a software engineer for over 20 years now. I probably need to update this slide. It's probably over 21 by now. I started out as a PHP developer back in 1999, and I got into front-end development and like the full stack type thing over time. So I've got a good understanding of front-end and back-end. Along that time, I've been really passionate about security and privacy and civil liberties and anonymity and all of these kind of things to do with identity. And I met somebody while I was speaking at a conference one day who worked at Auth0. And he said, well, if you're interested in all of these things and you like speaking at conferences and speaking to the community and helping them, you should work for us. So 7 months later or so, I decided to actually go for the job interview. And here I am today working at Auth0 and still being able to connect with communities like you and just make sure that like I'm able to share my knowledge, what I've learned over the years, but I also get so much more back from these things as well, learning about the challenges that you're facing. So I love these kind of, I can't wait for the more face-to-face things. Online has been fantastic, especially for the last year. And there's definitely value in being able to get this word further geographically. But I tell you what, I can't wait to go to an in-person conference again. All right, so enough about me. Let's get cracking with the actual presentation. So one of the things we're going to go through today is the different kinds of ways that we manage credentials. So usernames and passwords and all of these kind of things. And when we think of a credential type, there are a number of things that we will evaluate in order to work out whether or not it's a good credential. Generally, what we want with a good credential is something that's easy to remember because you don't want to have to write it down somewhere, but it should also be hard to guess or hard to clone in the case of things that aren't guessable. We'll come to the difference in a bit. And often these two can kind of go against each other. If it's easy to remember, then perhaps it's also going to be easy to guess. So trying to find a good password in that way can be tricky. The other thing that's important is being able to change it easily. If I've got a password that's easy to remember, and maybe it's also hard to guess, but somebody does manage to guess it or intercept it somehow, and we'll come to that in a second as well, I need to be able to change my password easily. What mechanisms are there for each of the different credentials that we'll look at for this? And then, like I said, hard to intercept. If a password is easy to remember and easy to change, but is really easy to intercept, then obviously it's not as secure as it could be. All right, so let's have a look at a graph. This is a highly scientific graph. I've basically got good, bad, and somewhere in between. I'm not going to put any numbers on this. The positions in here are quite arbitrary, but they're to give us an idea and to be able to analyze the different kind of credential options that we have nowadays with a view to working out where they fall within a kind of risk evaluation process. So we started off talking about passwords. Let's have a look at how passwords stack up for these three different characteristics. In terms of easy to remember and hard to guess, I'm going to score this pretty low. And I'm sure a lot of you will agree, passwords are often written down or they're reused because it's easier to remember one password for 17 sites than 17 different passwords. And in terms of hard to guess or clone, generally, like reusing passwords obviously makes it easy to guess on a different system. It's not very good. Passwords aren't very good for this characteristic of measurement. However, in terms of being able to change your password, it's really easy. Generally, a password is ideally a securely hashed in some way version of the password, but it's just in a database. So to update a password, you just replace that value in the database. There are certain security constraints around that, but technically it's not too difficult to change. And in terms of hard to intercept, I'm going to score it somewhere in the middle, but down towards the bottom. And while most websites nowadays will be over HTTPS, which means that when your credentials are being transmitted, they're secure in transit. We don't know how secure they are at rest, so when they're in the database. How easy is it to hack a database and get all the passwords out? And once you have all those passwords, it's really easy to stick them on the internet so anybody's got access to them. So intercept and access to those intercepts can be relatively easier than some other systems, but they are pretty targeted and they're very, well, I won't say rare, but I'm going to score it slightly lower than ideal, but still somewhere in the middle. It's not terrible, but there are certainly better options. So one of the things that you might have heard about is a website called Have I Been Pwned, which is run by a fellow Australian. It's basically a whole database of password breaches and there are APIs around it so that you can make sure that anybody who's signing up or changing their password with your system isn't using a potentially vulnerable password. But just the mere existence of Have I Been Pwned suggests that passwords are probably a credential mechanism that is not necessarily ideal by itself, and you would probably want to augment it with another form of authentication. And that form of authentication might be, for example, an SMS. And I remember while I'm going through these are all mostly hypothetical. I'm not attributing anything good or bad to any of these. There are certainly issues with SMS, but combining it can make you more secure. SMS itself is really easy to remember because essentially you don't have to remember anything. All you need to do is remember to have your phone with you in order to receive the SMS. It's relatively hard to guess or to clone. You would have to clone a whole phone in order to get an SMS. There are other vulnerabilities with SMSs. So there's the Ss7 protocol, which is basically, and you don't need to know, I don't even know the technical details of it, but essentially it's the protocol that the different mobile phone organizations use to transmit data between each other. So if I sent one of you an SMS, the likelihood is you would not be connected to Vodafone in Australia, which means that I've got to go via at least one other provider for that SMS to get to you. The Ss7 protocol is used for that communication, and there are vulnerabilities in that. They are targeted vulnerabilities, so you can't just say, I want access to all SMSs, but it is conceivably possible for somebody to receive an SMS to a phone number that they have specifically targeted for intercept. So it's slightly it's possible to do, but it's very hard and very directed. So hence putting this in the high performance category, but not right at the top, you'll notice. In terms of changing, it's a little trickier than a password. If you wanted to change the phone number that the code was sent to, you would have to go in and do some kind of verification process again. But essentially, it's still just changing the phone number in a database instead of the password in a database. So still in that green zone, slightly harder because there are other verification processes you need to go through. If I put a new SMS number in, I have to receive a text and confirm that that's actually my number, whereas a password, you just put the password in. SMS needs some kind of verification. And in terms of intercept, again, really hard. I've mentioned the Ss7 hacking, so it's still in the gray area, slightly harder to intercept than a whole password list, so therefore it's slightly more towards the green. So on a whole, SMS is looking like a better credential mechanism here, notwithstanding some of the intercept issues. And then how about something like voice? Voice itself is a mechanism that's really easy to remember. I don't remember the last time I left home without my voice, unless I had the flu, or I'd been singing a lot the night before at karaoke, or a number of things that can happen to change your voice, which may or may not impact the system that's trying to determine whether it was not it's you. So there's technical implications to this as well. I'm losing my voice at the moment, for example. How would that affect me being able to log into a system? But by and large, really easy to remember. I always have it with me. It's really hard to change, though. And unless I'm somebody who's able to impersonate somebody else's voice perfectly, and again, that's going to be a targeted thing. You'd have to train a long time to be somebody else's voice. But by and large, it's really hard to change your voice, which can be a good thing, because that's the whole point of voice recognition, is that your voice doesn't change. But if your voice pattern somehow in the future magically gets leaked and somebody can now use your voice in some way, you can't change your voice with the system. But intercept is quite hard. So you can intercept with a microphone and a speaker and playing it in somewhere, but generally what happens is you have to read a certain phrase. So the likelihood of being able to get my voice and then log into a system by reading out a specific phrase that's displayed to the person trying to access, you've got all sorts of complications and intricacies there. So voice is probably slightly harder to intercept than an SMS, which is harder, which is harder to intercept than a password. So you might notice that these three particular ones that I've taken as an example represent what we commonly refer to as the three primary multi-factor factors. There are other factors as well, but usually the factors that we look at here are the something you know, like a password, something you have, like a phone, and something you are, like your voice. So you've got biometrics, physical, and what's in your brain. There are a whole lot of other systems that fit into these as well. So a PIN number would be similar to a password. That's something you know. An authenticator app would be a replacement to SMS. That's something you have. And if you've ever seen client certificates, these are public-private key kind of certificates that you can install into a browser. The browser can send those to designated servers in order to provide something almost like a biometric type. It's not biometric, but it's also not something you have or something you are, something you know. So it's another way of portraying identity to a server in a internet client server type of mechanism like that. If you take pins and passwords and all the things that you know out of the equation, this is what we commonly refer to as passwordless. So passwordless is essentially any credential mechanism that is not a password. That kind of stands to reason. And another one that we can add into the mix here is the Fido Security Key. So that's a little bit like, I don't actually have one in front of me right now, but that's a little one of these like little USB keys that you can stick into the side of a computer. And you touch it to prove that you're there, and it does some kind of work on it in order to be able to verify that the person is there. And we'll look at this a little bit further because that's basically the essence of Webauthn. So we'll look at that further in a bit. But essentially, if you have a look at these and also client certificates, they are really easy to remember because you always have them on you. They're really hard to guess. You can't actually guess because it's public-private key encryption, and they're really hard to clone. That's the whole point of these hardware devices, is you can't clone them so easily. They're quite easy to change, so they're probably about as easy to change as voice or SMS. A little bit, just SMS and passwords. They're a little bit harder again. In the same way as SMS, you need to do this verification thing. Here's my new number. Yes, I've received the text. Here's confirmation that I received that text. You have to do the same thing with the Fido Security Key. So I've got one key already that's registered. I want to change to use my second key. So I've got to plug that one in, and I've got to register that one, and I've got to do a confirmation. So it's still relatively easy. It's just data in a database. But there's one or two little steps you have to take in order to change which security key you're going to log into any given mechanism. And in terms of intercept, this is extremely hard. So this is one of the biggest benefits, and we'll come to this in more detail soon. One of the biggest benefits of Fido Security Keys and Webauthn is intercept is extremely difficult, if not impossible. I'm not going to say it's impossible because at some point in the future, somebody's going to invent a supercomputer that can actually break it, probably. So I'm not going to guarantee it'll never be broken, but it's so hard, it might as well be classified as impossible right now. All right, so these two client certificates and the Fido Security Key are what we call phishing resistant, and that is that it's impossible, in quotes, again, 99.99999% impossible to phish any of these details, which is what makes Intercept so hard. So let's have a look at the process of what phishing is. So imagine you're a user. The user is in green. We're going to classify green users as good. So this, you've received an email from apparently from Google, and it says, hey, you're running out of storage space. Click here to upgrade your account. And you click on the link, and it takes you to a Google login page. But what you don't actually notice, because your brain is spongy and a pile of meat, it's not actually, it's easy to trick. So it's actually g00g1e.com, but you haven't noticed. But it looks like Google, and you're like, yep, that's fine. So I'm just going to log in. Here's my username and password. And then what happens is you get taken, you provide your correct credentials, and you get taken to a fake success page. What happens in the background, though, is your valid credentials are sent off to some malicious person. The malicious person is obviously in red, because red is bad, apparently. Who makes up these rules? I don't know. But this bad person, let's say it's me, for example. You've just logged in, and I've received in some way your valid credentials. Or more likely, those credentials have come to a script that I have running on a server somewhere. And what I'm going to get my script to do is to send those to Google servers and say, hey, I want to log in as this person. Here's my username and password. Now, at this point, Google could possibly do something like, hey, I need your authentication code, like the 6-digit number, or I need you to click OK on your Android device to make sure that you're actually who you say you are. Now, oftentimes you might think to yourself, well, as a malicious person, I don't have access to that number because I got sent to you, or I don't have access to the authentication device because that's something you have. But what I can do instead is I can update the fake success page in real time using some kind of WebSockets to say, hey, I require your 6-digit number, or hey, can you click the OK button on your Android phone? And because you think you've just logged into Google and your brain is mushy meat and you can't actually distinguish between the phishing site and real sites, that's not an insult or an insinuation of any kind of negative. It's just the way our brains work. We're easy to trick. So I sent you that message, and then I get that response. So I can then send that response to Google. Or you've clicked OK on your phone, and Google says, oh, yeah, that was you logging in because you thought you were logging in. So what does Google do? It sends me to the homepage logged in as you. So that's essentially how phishing works under the hood. And you'll see that the main principle of phishing, the main reason why phishing can work, is that it relies on that fake login page. The fake login page and the fake success page, as long as they look reasonable enough, as soon as you provided those credentials, automatically through scripts at the back end, without any kind of human intervention, within seconds, your account can be compromised. And that's one of the things that Webauthn and the Fido Security Keys are designed in part, but it's one of their primary advantages to solve. So let's have a look at how Webauthn actually works. This is the juice. This is what you came for. All right, so we're now going to go to purple, because we're not going to insinuate good or bad. This is just generally operating websites on the internet. So you've come to this new site, and you want to create an account. So traditionally what you do is you click on the Create Account button, and it will give you a form that says, please enter your username and your password again, just in case you can't type it properly, and then maybe some other details. With Webauthn, what you do instead is you send a request to a server saying, hey, I want to create an account for Ben. So you provide that in advance already. So what you do is you get a form that says, enter the username you want to use. You hit register. And what happens then is that the web application that you're trying to create an account on will send a message to the backend server, the API, or the backend to a regular web application, and say, hey, we want to create a new user with the username Ben. So the web application is then going to generate some kind of challenge. And this is basically a cryptographically randomly generated string. There's nothing really in here other than a bit of string. And basically the challenge is to sign that string in some way. And as we work through the process, you'll see how that all ties together. So we've got this random string, essentially. Meanwhile, the server has created a record for a user. It's an incomplete record so far. It's just basically said, creating user Ben, and we've sent them this challenge. So that challenge gets sent back to the web browser, and the web browser will then use the navigator.credentials API, which is built into most of the latest browsers nowadays. Navigator.credentials is basically the API component that talks to Fido Security Keys. or Webauthn keys, if you want to call them that. So basically, phishing is a type of online scam? Yes, definitely. Very, very much a scam. So two-factor authentication can be a savior in these kind of scenarios. I'm not sure which scenario you mean there, Surav. One of the issues with phishing is that you can actually still phish that second factor in some way. Like I mentioned, if Google sent you an SMS and I tricked you into giving that to me through the fake page, there's still a way there for me to get through. It certainly makes you a lot more secure. I'm not saying don't use multi-factor authentication or multiple factors. They definitely all add layers onto that security model. But in cases where you need to be absolutely 100% certain that phishing cannot happen, that's where a Fido Security Key or Webauthn will come in useful. So we're going to call this navigator.credentials endpoint, we're going to call the create method on it. And into it, we send the challenge. That's the part in the middle there with the question mark on it. So that's the challenge we got from the server. The other thing that the browser is going to add into that request is the web origin. And the web origin is basically the domain of the website you're looking at. So that'll be google.com, for example. In this case, we're trying to create an account on yourwebsite.com. So this will be yourwebsite.com, and here's the challenge. And those get sent into the Fido Security Key. So the Fido Security Key will then, because it's a create, will create a public-private key pair. So the I with the line through it there is the private one. We never share that. And the I with the open I is the public key, and we can share that. And it'll take the private key, and it'll take the challenge that got sent in, and it's going to sign that challenge with the private key. So now what we have coming out of the security key, the Fido Security Key, is the public key and the signed challenge. That public key and the signed challenge are then returned back to the web browser. So remember, the web browser made a request with a challenge and also the web origin, and it received back a signed challenge and the public key that corresponds with the private key that just signed that challenge. The browser will then immediately, without any user intervention, send these details back to the server we're logging in with, unchanged. So again, the signed challenge and the public key get sent through to the server. And the server can now store those. What it'll do is it'll receive those, and it'll store the public key against the user object that was created. So remember in that first step, it created a user object, username Ben, and here's a challenge we sent. So it has that challenge and the username. And what it's now going to do is it's going to look at the original challenge and make sure that the signed challenge it received is signed with the public key that it also received and is valid for the original challenge that got sent out. So it's kind of closed the loop there. I sent you some information, you signed it and returned to me, and I can verify that the public key that you sent with the registration process matches the key that you signed. And we'll see how that then works for a login process. So that gets stored on the server. Server now has a public key for me and my username. It'll also have what's called a raw ID. I won't get into the technicalities of that, but it's basically an identifier of sorts. It could remember the signed key, the signed challenge. Doesn't need to. It's not really useful anymore after that. So let's say now we're doing the login process. So rather than just sending back a challenge, it's now going to send back a challenge and also that raw ID I mentioned. Hey, I know that you're logging in as Ben. We already have an account for you. Here's an identifier that we have for your account, and here's another challenge for you to sign. So that challenge and the identifier then gets sent through to, let me just go back one, gets sent through to the security key by the browser. And this time it calls navigator.credentials.get because we know that we're doing a login as opposed to a registration. So we want to get a signed challenge for this current user. So we've got the web origin in there again. So it's going to be yourwebsite.com. And then we've got the challenge and also the identifier, the raw ID. So when the security key then gets this, what it can do is it can pull out of its internal database and say, hey, I know that I need to find the private key for yourwebsite.com. Now, this is a really key part. If I was tricked to go to yourwebsite.com instead, imagine that's the phishing attack. Okay, it's slightly misspelt. When it comes to generating the signed challenge, the Fido Security Key is going to say, okay, well, I need a private key for yourwebsite.com, and it can't find one. So it stops it in the tracks. That's where this phishing resistance comes in. It can only pull the private key out again in the future if it's on the same website where it was generated in the first place. So a third-party website cannot force or cannot trick your key into generating a signature for a challenge for another website. It's just brilliant. It's very smart. So it'll pull the private key out, and it takes the challenge and it'll sign it with that private key and return the signed challenge back to the browser. And at this point, the browser will take that signed challenge and send that back to the server that you're trying to log into. And at this point, the server will be able to take that signed challenge. It already has the public key in your account. It doesn't receive a new public key. It only gets that the first time when you register, and it stores that in against your user object. So I'm trying to log in as Ben. I've provided my username. It's sent back the raw ID, a challenge. Those have been sent to my Fido Security Key. It's been signed, and now the server has received the signed challenge. It takes that signed challenge and makes sure that it's been signed with a private key that corresponds to the public key that it has in its database. And if those match, then it knows that the signature was created with the same Fido Security Key. Therefore, it must have been somebody who had possession of that security key, and the assumption is that it's me. Now, that obviously is a downside to Fido Security Keys, is anybody could be in possession of it in the same way as anybody could be in possession of your mobile phone for SMS authentication. But Fido Security Keys often also allow you to put PIN numbers on them, same way as you can on mobile phones. So there are ways of making sure that the right person was using it. But essentially, what we've managed to do here is use one of these Fido Security Keys to create an account and to log in to that account again via public-private key signing, and ensuring that the same key is used every time the person logs in the future. And you can see when I mentioned before about changing your security key, if I had one security key and I wanted to change to another, or even add a second, you can have multiple keys to be able to log into a system. You would have to go through this registration process again for every key that you wanted to register against your user account. So there's a couple of steps involved, but it's fairly straightforward. And one of the things I love most about this is that the user interface or the user experience for your end users. Imagine this is, I don't know, some person in your life that you know who's not very familiar with computing, hates remembering passwords, doesn't remember how to, like, they type the URL they want to go to into the Google search box instead of the address bar. None of these things are wrong. Most people don't know computers inside out. But using a Fido Security Key for people like this is actually not that hard to do, because all they've got to do is remember to stick this key in the side of their computer, and when they're prompted to, press a little button, and it just works. And that's one of the things I love about this, is really makes phishing resistant, highly secure authentication credentials available to the masses. So there are still a couple of teething issues in some of the browsers. It's definitely getting a lot better. First time I started looking into Webauthn was about 18 months ago, and we're so much way ahead of where we were back then. Some browsers, for example, I run Linux on my laptop, and there are some features of Webauthn that don't work for me because of the various browser compatibilities across the platforms. But if you're on Microsoft Windows or Apple OS, what's the MacBook one? macOS, that's the one. They keep changing it. It used to be something else. I know it was iOS who changed their names. Anyway, I ramble. I tend to do that a lot, rambling. The user experience is so much easier on those. So what I want to do is give you a bit of a demo. Now, unfortunately, the reason why I don't have my security key on me is because it actually got broken the other day. It's a little bit embarrassing. I ran over it in my car. So that's not working at the moment. But what I want to do is I do want to give you an idea of how you can do a quick demo. And maybe if you've got... not all phones supported either. It's demo time. Yes, indeed. We'll see how this demo goes. So I've got a Pixel 4 here. And unfortunately, Android facial recognition is not a valid unlock. So let me just take one step back a second. So I've mentioned these security keys, and these are things you can plug into the side of your laptop. You also have FIDO capabilities built into some devices. So MacBook Pros with the touch fingerprint, for example, they are FIDO compliant. So you can actually log in through Webauthn by touching the fingerprint on your MacBook Pro. If you've got a Pixel 2, the fingerprint reader on the back of that works as well. Unfortunately, I don't have any devices at the moment that actually are FIDO compliant that work, because I broke my key. But what I want to do is show you a demo anyway, and then you can run through it if you have a key yourself or a device that works. then you can run through it at your own leisure. So I'm just going to switch over. The website I'm looking at here is webauthn.me. So I'll just copy this into the chat in case. I don't know that I can actually post a comment. I can't. Maybe I will see. I've just posted that into the private chat. If somebody can post that into the main comments so people can follow along if they would like to, that'd be awesome. Thank you. Okay, so this is basically a tool written by a colleague of mine who works at Auth0 as well. And it's a way for you to see Webauthn in action. Now, the step-by-step flow that I just took you through over here, this diagram, I was able to slow it down and talk about every step. You'll notice as we go through this, at least the first part that we can do without the web authenticator, is it flows really quickly. So that's why I wanted to take you through step by step before as well, to give you a bit more of a gentler introduction before you start seeing things flying all over the place. So let's have a look at this. So once grab yourself a YubiKey if you have one, or a Pixel 2 or something, or if you've got a MacBook Pro with a touch thingy on it, that'll work as well. So essentially what happens, and like I said, you don't provide a password when you register, you just provide a username. So you say, I want to register and my username has been, and you'll see here we've got the authenticator, the browser, and the relying party, the site that we're trying to log into. So when we register, the browser sends a challenge to the server, which gets returned and then goes back to the authenticator. Now you can see here at the moment that it's asking me to touch my security key, and it's not going to work. But what would happen here is the security key would then transmit back to the browser and we would get our new credentials back. What I might actually do, if we have a bit of time, I can I'm going to try something. Indulge me for about half a minute or so. I'm going to try joining the StreamYard thing here from my MacBook Pro, and then I might be able to do that demo. I just have to type the URL in because I can't copy and paste between different computers. I was about to start reading it out, but I probably shouldn't do that because this is live, and we could have anybody joining in. Let's see if this works. So I'm about to jump in here and share another screen. So if that comes through, if you could add that to what's going on here. Okay. Ugh. I really want to show you this this demo working, because it's so much better when it is actually working. And I was really bummed when I noticed about half an hour ago that my key wasn't working. So let's try this. Unfortunately, I recently did an update to iOS, so I've had to do give Firefox permissions to record the screen, as it's called. Oh, come on. Oh, here we go. All right, let's type that in again. StreamYard.com/ what was it? There we go. All right, let's try this. Sorry about this, folks. If I'd thought about this option earlier, it might have been a good idea. All right, let's share the screen.
Ben, are you facing any problem?
Look, the problem is, I can hear myself. Yeah, it's the. I'm going to take my headphones off because I can hear me through your microphone, which is throwing me off. The MacBook Pro is currently having issues sharing to StreamYard, so unfortunately, I'm not going to be able to share that one. But let me see if maybe Yeah, no. Unfortunately, I don't have any working Fido keys. That one is broken.
Sure.
And
Sure.
the MacBook Pro isn't working.
We have a lot of questions coming in from the audience.
Let's do some questions then.
So, sure, definitely.
Switch back to here, and we'll do that one. And I'll thank everyone for their time and all those things, and say thank you. Any questions?
Yeah, sure. Let me just flash some questions for you so that you will get started. Okay.
How can you make a career in cybersecurity? So the way that I got into it, and I wouldn't really call myself a cybersecurity person. I'm very interested in security. I don't do things like penetration testing. I've done some security audits where companies have asked me to review their code. One specific example that comes to mind is a company that had bought another company just for their code and wanted me to make sure that it was all secure. My trajectory into security was just by having that passion in security early on and focusing on that in things that I did every day. And I'm not going to say this path will work for everyone, but generally the way that I've managed to get into things is by just pursuing it as a hobby to the point where it just takes over my everyday work. So the fact that I got hired to do that security audit was based on the fact that I used to give talks at conferences around security, and I worked for companies and had done some security work for them. Most of my work is still in mainstream development, so I'm probably not the right person to ask how to get into cybersecurity specifically. But my recommendation to anybody who's asking, like you, Ushmita, is basically to live now the job that you want in the future. Do it as a hobby. Learn as much as you can. And one of my favorite ways of learning is by teaching. You learn so much by trying to explain things to other people that maybe learning enough to give a talk at a local user group would be a great way for you to get more and more into cybersecurity. Fido Security Key is similar to USB flash drive, so is it hackable? So the security key uses USB as an interface, but it's not actually a flash drive. It's actually a little mini computer that connects to your device. And on there is a whole load of software that will generate public-private keys and do challenge signing and those kind of things. So is it hackable? Not really. There's a lot of encryption wrapped around the code itself. And even if you could hack it, like I'm not sure, like externally hackable, like can you get access to my security key? No, you'd have to have physical access to it. You can't access it through the internet or anything. It has to be a locally present device. Could you reprogram it and do your own thing? To be honest, I don't know, but if you did, by that point, you've negated the purpose of that one key that you have access to. So it's not hackable in that way. I hope that makes sense. If you have any like further questions to kind of focus down on any particular question you're trying to get to, please add another one in the stream. Phishing is dependent on social engineering. Look, to a certain extent, you can. To me, the idea of social engineering is actually getting on the phone with somebody. It's engineering a social conversation or a construct. Insofar as phishing tries to get you to believe that the website you're logging into is actually a different website. I suppose that is also social engineering to a certain extent. But in any event, what both of those do is it uses the fact that our brains are basically, we're no good at noticing slight differences. One of the reasons why when the web origin gets sent in, one of the reasons why the Fido Security and the web origin makes us so much more secure is that computers don't get confused by domain names. A string is a string, and if you compare it to a string that looks similar but is different, a computer will always tell you these don't match, whereas a human brain will sometimes tell you they do match. So yes, from that perspective, it's definitely based on that kind of construct. How to detect it's a fake login page. This is really hard. There's been some posts in Twitter recently that I've seen where some URLs, I think somebody posted one the other day of apple.com, and the A was not actually a standard ASCII A. It was a different character in the character set that looked so similar to the A that it was really difficult to tell. So human-wise, I'm not going to say it's possible every time to be able to detect. You can certainly improve your chances of not being a victim of these things, regardless of whether or not you can use Fido Security Keys or Webauthn to log in. Doing things like making sure that the first time you log in somewhere, you add a bookmark and you only ever go to that website again through the bookmark is one way you could improve your odds. I'm not going to say that that's going to be foolproof. Maybe you might accidentally add a second bookmark at some point and it might actually be to the wrong one, but these kind of things can keep you more secure. Always typing the URL in is probably another way as well. It's certainly tricky. My general advice is if you think there might be an issue, then just believe there is and find a different way to do what you're trying to do. The phishing attackers are just getting smarter all the time. And while technology can do so much to help us keep us more secure, they're always going to be not necessarily one step ahead, but one step in a different direction maybe that we haven't quite covered yet, and people get tricked. I got tricked myself the other day. My friend got an SMS saying, "Hey, your bill is overdue. Click here to provide new payment details," and we did it, and then we realized that it was actually a form on a different website. So you will probably get trapped by this one day. I hope you don't. And if you do, hopefully it's something that's easily undoable and doesn't affect you. But just always being vigilant. Should we take the terms and conditions as granted? I'm not quite sure what you mean by that question. If you could rephrase that and come back to me, I'd love to dig into that a bit. Are phishing and spoofing the same thing? So phishing often relies on spoofing. Spoofing is kind of an element of it. You have to spoof a login page. There's a lot more to it, though. You need, like, I could spoof a Google login page, but then what happens to what you submit? And what happens if an SMS code is generated? How do I get that in? So there's it's one small component of phishing. And spoofing can also be a small component of something that is not phishing. So it's a component thereof. Yeah. How to calculate port number? Which port number? Come back to me with more information. I'm not sure which port number you're trying to calculate. Blockchain technology is secured how? So I don't actually know that much about blockchain, to be honest. I know a little, but not enough to answer that. And it's not really related to this talk either. Sorry about that. Can a message be decrypted without the private key when RSA is used to encrypt? No. So public-private keys, you use a public key for encrypting and a private key for decrypting, or use a private key for signing and a public key for verifying a signature. If you encrypt with a public key, you can only decrypt it with a private key. Can we register Webauthn now by putting our email ID? So I think there might be a little bit of confusion either in the question or in my interpretation, but you don't have to register for Webauthn. Webauthn is like an alternative to a password. So you don't register for a password. You use a password in order to create an account, and you can use Webauthn to create an account in a system as well. Once I've seen an article using an on-screen keyboard for your password and for other imp details as much safer, could you please elaborate on this and how using an on-screen keyboard? So one of the reasons why on-screen keyboards can be safer is that if you're typing on a keyboard, you can get USB loggers, either hardware ones, or there could be software residing on your machine that is intercepting the keyboard and kind of taking a copy of what you're typing in real time. On-screen keyboards can eliminate some of these issues. However, if you're trying to eliminate the issue of, say, a rogue plugin or a cross-site scripting attack getting access to it within your web browser, then they can still watch the listen events on the buttons. If somebody's looking over your shoulder, they can see which buttons you're pressing. Also, depending on how you implement the on-screen keyboard, you might be eliminating people's ability to use password managers, which in my book is a really bad idea. So generally, if I was going to advise anybody on creating any kind of interface for logging in, I would stay away from on-screen keyboards. What's the importance of the Caesar cipher technique in system security? I don't know, to be honest. Does Auth0 have an easy way to integrate into frameworks like React? Absolutely. Let me just show you very quickly. If I log into Auth0, this one here, using my personal container. This is what the interface looks like for Auth0. And if I come into applications and I create a new application, if I want to create a React app, for example, I would choose single page web application here. So you can have a native, if you're developing for desktop or mobile apps, then you'd create a native type application, single page apps. Regular web applications would be like your Python or PHP backended applications that generate the HTML output. And then you have machine to machine where you've got two APIs that need to talk to each other, for example. So we're going to do a single page web application here. If we hit create, we can come in, we start in the quick start. We can quick start with React. And you can either start by downloading a working sample, or the main way you do it, obviously, this is going to take you through step-by-step exactly how to configure Auth0. And it's really easy to follow through. So I definitely recommend you have a look at this. But essentially, the main thing you need to do is install Auth0/Auth0 React, and then add this into your to wrap your application with this Auth0 provider, and that's it. That's the integration done. After that, obviously, you need to do things like creating a login button and blocking routes depending on whether or not they're logged in. But the integration part, absolutely so easy to do. You'll do it in, after you've done it a couple of times, it'll take you 5 minutes. And just as an idea, like you saw 4 examples of different types of applications, single page applications. If you create a regular web application, we have so many different, like there's 15 here, but there are so many more SDKs than this. So most of the languages and stacks that you're going to be building with, if you want to integrate with Auth0, it's fairly straightforward. Can machine learning and artificial intelligence-based models decrypt the message? And if not, why not? Not really, because there's no way to learn how to decrypt cryptographically secured data. The best that an ML AI-based model could do is to do brute force, in which case you might as well just do brute force. And the permutations of keys and the complexity of decryption, it's just, I mean, you could do it, but it's going to take you, I'm guessing now, billions of years. So no, computers aren't fast enough. How does the site like I've been pwned website know that our email has been compromised? So what there's originally what happened is this is my understanding anyway. Originally what happened is the author of the website, a guy called Troy Hunt, would hear about database breaches through actually seeing the leaked data sent on, I don't know, through Tor sites or whatever else. So he would become aware of these database leaks, and he would add them into his database so that you could search to see whether or not you had been compromised. Over time now, he's actually had, when companies actually detect their own breach, they sometimes work with him directly to say, here's a list of all the breach information we've got, so that obviously they have to notify their users anyway, but at least that data is then elsewhere. One of the advantages of having all this data in one place, and Auth0 uses this API, is you can actually ask the Have I Been Pwned API for a rating of whether or not a particular password has been used before. And if the password has been used, if it detects that I'm reusing a password, you can actually dissuade people or even stop people from creating an account with a reused password, which I think is quite cool. Who are anonymous groups peoples? No idea, they're anonymous. Is SHA-256 encryption and salt encryption type of passwords much more secure, or is it decryptable? So I'm not sure what you mean by SHA-256 encryption, because SHA is a hashing algorithm, not an encryption algorithm. However, RSA, which is an encryption algorithm, uses SHA for hashing inside it. But generally, if you're looking at SHA plus salt of passwords, you're probably looking at hashing, which is definitely more secure because you cannot reverse, well, it's mathematically and cryptographically improbable that you can reverse engineer a hash. Whereas decryption is supposed to be two directions. You're supposed to be able to encrypt something. Oh, my camera just died. You're supposed to be able to encrypt something, and also, I'm just going to replace my camera battery, so I'll be back in a second. Whereas with hashing, the whole idea is that it's a one-way. So when you're verifying a username and password, the password comes in and it gets hashed, and then you compare the hash with what's in the database. That means, oh, actually, apparently my camera's overheating, so that's why that's not working. Apologies about that. I will I will just have this instead, no signal. So yes, to answer your question, hashing is definitely more secure than decrypting passwords because you never want to be able to get back to the original password. There's no reason for any person other than the person who knows the password to ever know the password. So I hope that makes sense. Exactly what kind of work do I do at Auth0? This kind of stuff. So I'm a developer advocate, which means that I basically interact with the community. My history of running conferences and meetups and giving talks at conferences is why I got into this role, or why Auth0 invited me to get into this role. The thing that I love about it is learning new stuff, being able to share what I'm learning with the community, and getting feedback from you all as well about the things that are important to you. The reason why Auth0 has me work for them is because I can find out from you how you're using Auth0. Maybe there are some better ways that we can support you. And also, often you as a developer never have access to the developers in the organizations whose products you use. For example, if you use Microsoft Word, you can't speak to a Microsoft Word developer to see whether or not they can help you with a certain issue. Whereas if there's an issue that you have, or even a feature suggestion or a bug or any of these things, if I learn about these things, then I can consolidate these, and some of the important stuff will get sent back directly to our development team. So it's mainly interacting with the community in that way.
So I think that's it. Like, we have more questions, but I think that's it because you have answered a lot of questions. And thank you so much, Ben. It's been an amazing session. A lot of things
You're welcome.
our audience have learned, and we got a lot of good response as well. We had more than 150 plus participants watching your session, taking in inspiration, taking
Brilliant.
in a lot of knowledge, and like the whole session was interactive. Okay, and the questions also which like they came up with, I think that they were very much like related to your session, and I hope you had a great time here.
I did. I had a great time. Thank you, everyone, for joining and for the questions as well.
Yeah,
and also,
so just
my contact
flashing
details are on the screen, so get in touch if you've got any questions that we didn't have time
yeah,
for.
sure. So just flashing the good comments which are about your session. Okay, so just flashing them so that you can read them.
Sure. Thanks, Adash. Good vibes. I'm glad you thought it was good vibes. Demo fails are always disappointing, but a little bit fun and exciting at the same time. Yeah, good. Thank you, everyone. It's great. It's always nice to get good feedback like this. You're welcome, Ritu. I see lots of general thanks in the comments as well. You're all very welcome. I'm glad you were able to join us today. What's the elbow cough?
now there are a lot of now that I'm flashing all these things, a lot of again a lot of comments are coming.
Yeah, that's all
It's
good.
just flowing.
That's all right. Thank you for hosting me. It's been so much fun.
A lot. It's just coming and coming and coming. It's like that. So.
Okay. Well, I'll give a general thank you to everyone then, rather than going through them all. But I'm glad it was useful. I'm glad people got a lot of valuable information out of it. And like
Definitely.
I say, contact details there on the screen. It's not 100% obvious either, but Ben Dechrai down here, the username is my username on Twitter. My DMs are open, so you can contact me that way as well.
And I want to say to all of you who are live right now, we have mentioned all the details about Ben, what he does at Auto, and all the details. I also his LinkedIn handle is mentioned, so do connect with him on LinkedIn, ask him questions, okay, interact with him. He's a very good person to talk to. And it's been an amazing day, Ben, and thank you for kicking off our very first session. So we have sessions on weekends, but yours was the very first session. Like today,
Awesome.
we kickstart with our contribution program where our contributors are going to contribute for the next 30 days. And these sessions are specially organized for them on weekends so that they can learn from people like you and take an inspiration, taking a lot of knowledge, and also network with you so that
Awesome.
they can get like stay under your guidance and stuff like that. So
Totally.
a lot of people are saying amazing session. So truly it was a great session. Due to some issues we couldn't do the demo, but you answered the questions so well, and it's been an amazing day here. And we at DevIncept, we want to really thank you, a big thanks to you, and thank you so much for your time, for your knowledge, and for being here and accepting our invite.
I'm honored to have been invited. Thank you very much.
Yeah, thank you so much. And for everyone who are asking about quizzes and certificates, so there is a form which is given. You just have to fill the form and you will get like the mail on your mails, like the quiz, like details related to the quiz, and you can fill that. And after that, we'll reveal the winners, and those winners will get swags from DevIncept. Okay. So right now, you just have to fill the attendance form which is given in the that shows that you have attended the entire session, and then and only then you are available, like you are eligible for the like the swags. Okay, you are eligible for the quiz, and we are hosting the quiz on Slack. Okay, we are not doing it on Telegram. Make sure you have like are on Slack. So we are doing it on Slack. And thank you so much everyone for attending this session. I know it was in the morning 10 to 11. It was a bit early, but I hope that you learned a lot. Okay, and you are taking in a lot of knowledge, and we want you to learn, we want you to grow, and that's the whole motto of all these sessions. So there will be another session giving you an update. So it's the topic is going to be introduction to open source and GitHub. So it's going to be taken by a developer as well. So he's going to be taking that session from 12 to 11. So we have a 1 hour gap in between. So make sure you attend that session as well, and you can join our Telegram and all those stuff. All the links are given in the description box below. So do join so that you can get exclusive updates about whatever we are doing in future and whatever sessions we are coming up with. And thank you so much for attending. Ben, hope you had a great day, and we are wrapping up the session now. And like any last words you want to say, like before we go? Like,
I just want to echo all of your words, and also thank you for getting up so early. It was 2:30. It's now 3:30 in the afternoon for me in Australia, and I appreciate you getting up early so I didn't have to be speaking late.
Great then. So we'll wrap this up, and yeah, so let's meet in another 1 hour where we have another speaker here, and looking forward to learn more and grow yourself. Okay,
have a great day, everyone.